We will see a problem, tutorial 3, problem number 4.2. So 5 identical charges or the point charges are located at the center and corners of a square defined by x and varies from x and y varies from -1 to 1 and z equal to 0. So we will first see what is the scenario. So this is z axis, this is the x axis, and this is the y axis, and the point charges are placed at, you see here, at x and y, which is varying from -1 to 1, and it is a square. That means that this is the direction of -x and this is the direction of -y. Now we will see how it is placed. So you can define a square like this because z equal to 0, so everything will be in the xy plane. So this is the square. So we will see x and y varies from -1 to 1 and y is x and y varies from -1 to 1 and z equal to 0. Now we will see the location of the charges. So here one charge is there, and one charge is here, and another charge is here, and another charge is here, and there is one more charge which is at the center. You can see it is here. Okay, now what are the coordinates for this? First of all, we have to see, and at this point you see when x and y's are positive, you can see that it is 1 1 and 0, because x is equal to 1, y is equal to 1 and z equal to 0. And here in the second point, you can say here, as I am showing here, you can see what is the value of x. X is negative because it is going in the -x direction, so -1, then y is positive, then z equal to 0. And the another one, the third one, is like x is positive, y is -1, and z equal to 0. And the fourth one is like you can see x is -1, y is -1, and z equal to 0. And at the origin, you can say there is one charge is here, is located here, so it is 0 0 0. So this is the location of the charges. Now in the question, it is asked to find what is the force on the charge which is 10 microcoulomb, which is placed at 0 0 2. 0 0 2 means x is equal to 0, y is equal to 0, and z equal to 2. So I will show with different color where is that point. So this is the point where 0 0 2. So the charge is placed here, and you can see both the charges are positive. The other charges are 15 microcoulombs. So this is 15 microcoulomb, and here it is 15 microcoulomb, and here also it is 15 microcoulomb, and here also it is 15 microcoulomb, and this charge is 10 microcoulomb. Now we need to find what is the force acting on the charge which is 10 microcoulomb. So the force will be acting like this, because this will be the force from the point charge as point charge at -1 -1 0, and you can see this is the force from the point charge at -1 1 0, and this is the force from this particular charge, and this is the force this is the force from this particular charge. So that means we will get a lot of forces. So first force, I can say this is my F1, and this is my F1, -1 -1 0, that is my F1. Then I will give some other names. So the first charge is like from the center, I will put it as F1. Let's say this is my F1. The second charge at 1 1 0, from the force from 1 1 0, I will put it as F2. The force from minus 1 1 0, that means this one I will put it as F3. Okay, then the force from 1 minus 1 0 I will put it as F4, and the force from minus 1 0 I will put it as F5. So what will be the total force which is acting on the 10 microcoulomb charge? It will be equal to F1 plus F2 plus F3 plus F4 plus F5. So we will find each term. What is my F1? F1 is equal to 1 by 4 pi epsilon 0, or I will write it in a combined way in the next page. So what will be my total charge? My total force will be equal to F1 is equal to 1 by 4 pi epsilon 0 into Q1. What is my Q1? The Q1 is 15 microcoulomb, and everywhere it is 15 microcoulomb. So 15 microcoulomb into 10 microcoulomb. So this will be a common term because everywhere the charge is same, that is we have 15 microcoulomb everywhere. So it will be so this will be a common term. So into we will see what is my vector in this direction. For example, if I am taking the first force F1, I will use a different color. The first force F1 will be having some vector distance which is like R1. So what is my R1? So you know that it is like R1 divided by the magnitude of R1 the cube, right, plus from the second one. What is the second one? It is 1 1. The second force is like it is from 1 1 0 to 0 0 2. So this is the force, this is the vector which is from 1 1 0 to 0 0 2. So it is like R2 divided by the magnitude of R2 the whole cube, plus then for the force F3, you can say this is your R3. Okay, so it is the vector which is pointing from this particular point to the location where the other charge is located. So you can see it will be like R3 divided by the magnitude of R3 the whole cube, plus similarly you can also write R4 divided by magnitude of R4 the whole cube, plus R5 divided by the magnitude of R5 the whole cube. So this is the formula. So now we will see what will be F total, which is equal to, you will get this term, this is epsilon 0, you know that epsilon 0 is equal to 8.85 into 10 power minus 12 farads per meter. So if you do this calculation, you will get this as 1.35. okay, 1.35 into what will be R1. So R1 is the vector which is pointing from 0 0 0 to 0 0 2. So it is like 0 0 0, the point 0 0 0 minus, sorry, it is pointing from 0 0 0 to 0 0 2. So it is like 0 0 2 minus 0 0 0. So what it will be? So first of all I will write it in a different way. What is R1 anyway? So my R1 is equal to, it is pointing from 0 0 0, it is pointing from 0 0 0 to 0 0 2. So it will be like 0 AX plus 0 AY plus 2 AZ that is the position vector of 0, 0, 2 minus 0 ax plus 0 ay plus 0 az. This is the position vector of 0, 0, 0. So, this will be equal to 2 az. Okay. So, I hope it is clear to you. Then the vector r2 will be equal to the position vector which is r2. R2 is the vector which is pointing from this 1, 1, 0 to 0, 0, 2. So, what is the final point? It is 0, 0, 2. That means 0 ax plus 0 ay plus 2 az minus, it is pointing from 1, 1, 0. That means ax plus ay plus 0 az. So, you will get it as minus ax minus ay plus 2 az. Okay. Now, you will now we have R3 which is equal to the same rule you can apply. R3 is actually this vector. Okay. So, R3 is this vector. So, you can see R3 is pointing from minus 1, 1, 0 to 0, 0, 2. So, again we will write the same point 0, 0, 2, 0 ax plus 0 ay plus 2 az minus, what is the point? It is minus 1, 1, 0. So, minus ax plus ay plus 0 az. So, this will give you ax minus ay plus 2 az. So, in the similar way you can find R4. R4 is like, R4 is pointing from, you see here R4 is for F4. So, F4 is the vector, this is the R4. So, it is pointing from here. Okay. So, it is pointing from here. So, you can see here it is pointing from 1, minus 1, 0. So, it is pointing from 1, that means ax minus 1, 0. Okay. Minus 1, 0, and it is pointing to the same point 0 ax plus 0 ay plus 2 az. So, this will give you minus ax, then plus ay, okay, minus ax plus ay plus 2 az. Then you will get next as R5. So, it is also pointing to the same point. So, 0 ay plus not 12, it is 2 plus 2 az minus, what is R5? It is, R5 is the corresponding vector for F5. So, F5 is pointing from here minus 1, minus 1, 0. So, it is like minus 1 means minus 1, minus 1, 0. That means this is the point. So, here you will get it as ax, okay, ax, then ax plus ay, then plus 2 az. Okay. Now, we will also find what is the magnitude of each one. So, what is the magnitude of this? Magnitude of R1 cube will be equal to, what is the magnitude of R1? It is 2, because it is square root of 2 square, that is 2. You will get it as 2 cube, which is equal to 8. Similarly, the magnitude of R2 cube, you will get it as, you see here it is minus 1 square root of minus 1 square plus minus 1 square, that means 1 square plus 1 square 2, 2 square plus 4, that means 1 square plus, that means 1 plus 1 plus 4, that means you will get it as root 6. So, root 6 means 6 power 1 by 2, then you have to take the cube. So, it will become 6 power 3 by 2, and here also you will get it as R3 cube, you will get it as 6 power 3 by 2. and here also you will get it as 6 power 3 by 2, and here also you will get it as 6 power 3 by 2 R5, 6 power 3 by 2. And this combined term what I have shown here, this you will get it as 1.35. So I will write the equation in the next page. So you will get the force, total force is equal to 1.35 multiplied with, you see this is AZ, so I will take AZ, so 2AZ, to 2AZ divided by what is the magnitude cube, that is just 8, plus, you see here this vector is minus AX plus AY plus 2AZ, so minus AX minus AX minus AY plus 2AZ divided by, what is it, the magnitude cube is 6 power 3 by 2 plus AX minus AY plus 2AZ, AX minus AY plus 2AZ, okay, divided by 6 power 3 by 2, that is the magnitude, plus then minus AX plus AY minus AX plus AY plus 2AZ divided by 6 power 3 by 2, all are having the same magnitude. Then AX plus AY plus 2AZ, AX plus AY plus 2AZ divided by 6 power 3 by 2, okay. So this is the combined term. Now you can see that the denominator of all these terms are same, so I can directly add. If you add it, you will see that the terms corresponding to x or AX, that means this is minus AX and you have plus AX. Similarly, you have again minus AX and plus AX, and all these terms are same, so you can directly add it, so it will cancel. And also you see here minus AY minus AY, this is plus AY, again all these will cancel. So what will be remaining? So the total force F will be equal to 1.35 multiplied with, this is 2 by 8, 2 by 8 you know it is like 0.25 into AZ, plus you will see only one term, you have like you have 2AZ, 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 so it become 8AZ, then divided by 6 power 3 by 2, okay. So you will get this answer as 1.72 into AZ newtons. That means the direction of the force, the total force, the combined force will be towards the Z direction, just only up. That means all the horizontal components will cancel each other. So this will be the direction of the force. So I hope it is clear to you. Now you know that now the second part of the problem, is to calculate the electric field. So electric field, now we know the total force, and this is the total force on which charge it on 10 microcoulomb, right? This is the total force on 10 microcoulomb, right? So this is the total force on 10 microcoulomb, and we know that the electric field is given as F divided by that particular charge, and here that charge is 10 microcoulomb. So this is the force on, we have the total force on 10 microcoulomb. So we have the total force on 10 microcoulomb. So we can just divide this total force with 10 microcoulomb. So total force on 10 microcoulomb is 1.072 into AZ newtons, okay, into AZ newtons. Let me remove this. So AZ newtons. So electric field is given as E, which is equal to F divided by Q, which is equal to 1.072 into Az divided by 10 microcoulomb. So you will get this answer as 107.2 kilo. Okay, and what is the unit which we usually used? This will be in kilo. So you can see that it is actually, you can use kilonewtons per coulomb, or you can use, sorry, I forgot to write Az. So this will be equal to 107.2 kilo newtons per coulomb, or we can say it is 107.2 kilo volt per meter. So this is the usual unit for electric field that I have already discussed in that class, right? So I hope it is clear to you. Thank you.